In this video, we're going to look at domain again. And this is actually the first video. We're not going to learn a completely new technique. We're just going to look at slightly harder problems that involve some different things we haven't seen before. So if you know how to find domain from graphs, that's your starting point, and we're just going to look at some new things that could happen. So the main thing we're going to look at is having infinity as part of our answer. A lot of our domain graphs are like between -2 and 4. They kind of have these ends. What happens if your graph goes off in one direction? So let's look at this one. So domain, hopefully you remember, is your x values. So with this graph, my graph kind of starts here at this x value -3, but just keeps going, hits all of these x values, and you see this arrow means it would just keep going like this and keep hitting all these x values forever. So how could I write my answer? My answer is just my x values are everything that are bigger than equal to -3. So instead of having kind of this two-sided inequality that we're having a lot when we were having domains look like this, we had it like between -5 and 2. Here we just have a one-sided domain. X is just bigger than or equal to -3. So everything bigger than or equal to -3, I'm going to hit that x value. Here, we always kind of go left to right when we're doing domains. So if we start at the left, this is going left forever. I'm hitting every x value off to the left. And I keep hitting every x value. And it looks like I hit every x value there. And it looks like I hit every x value there. So you might think the answer for this one is everything. I hit every x value, but there's actually one specific value I don't hit. And if I were to draw, probably can't draw a perfectly straight line, but a perfectly straight line right here at 1. You can see on the left-hand side, this little left arrow is just on the left side of that blue line, and it's going straight up. So it never actually hits that blue line. Same thing on the right here. It's just to the right of the blue line. It's going straight down, so it never actually hits the blue line. So this graph is literally everything but -1. So what we'll say is all real numbers. This means every number, but x is not 1. So when you see a graph like that looks like this, we'll talk about this more in the spring, but I can plug in everything except for where that one kind of weird thing happened, that really big spike. That really big spike happens, that's not going to be a value you can plug into your expression. This one is like the first example. We just have two different kind of things. So on the left-hand side, we start at -infinity. This keeps going here. So we have all these negative answers we're getting, but then it stops there at -7. So that one is x is less than or equal to -7. Less than or equal to, because it's to the left. And then we have this separate thing over here that starts at 2 and then keeps going forever. After that, I'm hitting all those x values, so x is bigger than or equal to 2. So I said these two different inequalities. I can't write it as a single one because it's two kind of separate domains. But next, x is less than -7 and x is bigger than or equal to 2. Here's one you can try on your own, similar to the first example, kind of similar to the other ones. What's the domain of this one going to be? Just think to yourself for a second. But the domain keeps going to the left forever, so it's just all the things that's to the left of 2. Because I start at 2, hit that x value, and I hit all these x values as I go to the left forever. And last one, again, try this one on your own. It's similar to another example we did. What is the domain of this one going to be? And the domain of this one is all real numbers. But x cannot be where that spike happens. That spike happens right there at 7. So it's all real numbers, but x is not equal to 7. So these are just some extra graph examples to see. Again, no skill check for these challenge problems, so just go ahead, go through those practice problems and see if you can figure out the domain of all these new types of graphs.